Welcome to 2819. I'm Sandra Dimes.
And I'm Daniel Almaguer.
And today's topic is on a dark theme. Dark matter.
Dark matter.
Yes.
Does it matter?
We don't know.
We'll
find
matter?
out. Yeah.
In Everyday Apologetics, we're going to hear from Michael Guillen as he explains what dark matter and dark energy are.
And in Science Faith Connection, Jeff Swearink will talk with Mike Strauss on searching for dark matter with particle accelerators. That sounds exciting.
Gonna be good. First up is gonna be Culture Talk. Sandra will be interviewing Dr. Hugh Ross on what is dark matter and why does it matter.
Let's find out.
Let's go ahead and check it out.
Now it's time for Culture Talk, where we talk about culturally relevant topics you can use to start conversations about your faith. And I'm joined today with astronomer Dr. Hugh Ross. Thank you for joining us.
Oh, my pleasure.
We're going to be talking about a deep topic, and that is dark matter. First, before we dive into its relevancy as far as sharing our faith, can you explain what is dark matter?
Well, dark matter is matter that does not interact well with light. Either doesn't interact at all or interacts very weakly. Now, we're made up of ordinary matter, made up of matter composed of protons, neutrons, and electrons, and that has the property of strongly interacting with light. So it's easy to see. I mean, stars are made up of ordinary matter, and because they interact with photons, they're bright. Dark matter does not interact with photons, so it's dark.
What is its function?
Well, it stabilizes galaxies and galaxy clusters. I mean, one of the quests of astronomers and physicists is to find the particles that comprise dark matter. But because they interact so weakly with photons, they're extremely difficult to detect. But we can see the gravitational influence of dark matter. So, for example, if you look at our Milky Way galaxy, the stellar disk is about 120,000 light years in diameter. But we see that there's a gigantic dark matter halo encompassing our galaxy that's about 2 million light years in diameter. And 90% of our Milky Way galaxy's mass is dark matter. Only 10% is made up of ordinary matter.
So if dark matter doesn't react well or isn't quite detectable in light, then how do we know it exists? And from what I've read, it's considered theoretical. So does that mean, like from an average person's perspective, if you say theoretical, it means, we don't quite know.
Yeah, some have used that term to say it's hypothetical. We really don't know if it exists, but we certainly see its gravitational influence. So there's something that doesn't emit light that is exerting a lot of gravity. And astronomers can measure with fairly high precision the ratio of dark matter to ordinary matter, and there's about 5 to 6 times as much dark matter as there ordinary matter. So what it helps to explain the amazing symmetry of our Milky Way spiral galaxy is the fact that it's stabilized by this enormous dark matter halo that encompasses it, and we see that for all galaxies as well as the structure of galaxy clusters. So astronomers have no doubt that this dark matter is real, and it's the second most dominant component of the universe, second to only dark energy, but we have yet to detect the fundamental particles that comprise dark matter, and it may be a while before we do, because they're going to be extraordinarily difficult to find.
Right. So from astronomers' perspectives, it does exist. You just haven't identified the particles. So if it makes up the vast majority of what's in our universe.
Well, it makes up the majority of the matter. Dark energy makes up 70% of the universe. Matter makes up 30%, but most of that 30% is dark matter.
So that is an important topic to kind of wrap our heads around, especially as we think about worldview. So does the existence of dark matter and its predominance, does that seem to fit well with any one particular worldview and maybe not fit well with other worldviews?
Well, for example, we wouldn't be having this conversation. We wouldn't even exist if there wasn't this high ratio of dark matter to ordinary matter. So yeah, dark matter is crucial to explain why there's physical life in the universe. It's part of the fine-tuning argument for the existence and character attributes of the Creator.
So you're saying that it is like attributes of the creator. So how would we articulate that if we're having a conversation with someone about dark matter? Conversation just happens to go to the topic of dark matter. How do we even engage in that?
I'll give you an example. My younger son was involved in a death metal band.
Oh, I remember that.
And it was called Channeling Darkness.
Yeah.
So I sat down with the 5 members of the band and said, would you really like to hear about cosmic darkness and how it makes up 99, says the stuff we see is only 0.27% of all the stuff of the universe. 99.73% is dark stuff, dark matter and dark energy. And they were all ears. Oh, you got to tell us about this. And I told them, make that percentage the tiniest bit bigger or the tiniest bit smaller, there'd be no life in the universe. They wound up writing some lyrics about the design of dark matter in the universe. And one of them became a Christian as a result. So that's just one example of how you can use this.
That's really interesting. And you bring up such fascinating talking points for something that maybe people might not initially be intrigued. If you said, let's talk about dark matter, they might not want to hear about it. But the way that you kind of unpack that, I think, makes it really interesting.
How do I intrigue their curiosity? Only 1/4% of the stuff that we see in the universe is stuff that exhibits light.
Wow.
The rest of it's dark stuff. Do you want to know why it has to be that huge quantity of dark stuff? That got their attention.
Well, it's got my attention for sure. I hope it's got our viewers' attention. And if they want to learn more, where would you point them to?
Well, my latest book, Designed at the Core, has several chapters that deal with the fine-tuned designs of the dark stuff in the universe, particularly the fact that our Milky Way galaxy is unlike any other Milky Way galaxy in that it has this enormous dark matter halo around it. Wasn't for that, again, we wouldn't even be having this conversation.
Well, thank you so much for that, Hugh. So viewers, if you would like to learn more about this topic, go to support.reasons.org and you can get Designed to the Core.
Will science ultimately tell us everything there is to know? I find it interesting that as we look at creation, we find a lot of things that are rather mysterious, like dark matter and dark energy, that just really cause us to scratch our heads and figure out what's going on. Well, today I'm joined by Michael Guillen, and we're going to explore what do we do with this dark energy and dark matter stuff? What does it really mean? Michael, it's good to have you here today.
I love that question. I love it. I love being here with you, Jeff. Yeah.
It's just kind of funny. I mean, you can't accuse scientists of being creative in their names at some level, but this idea of dark matter and dark energy, it's intriguing just because there's a lot of stuff we don't understand.
Yeah.
But ultimately, it's pointing to things that are so far beyond what we might expect.
Yeah.
As a scientist, what are we doing? What's going on there?
When you mention dark matter, let's start there. It takes me back to my grad student days at Cornell. We didn't really call it dark matter back then. We called it the missing mass problem.
Okay.
That's how that observation was framed. We would look out into deep space. We'd see the galaxies, twirling around. And we used something called the virial theorem to figure out how fast it should be spinning around. And lo and behold, it wasn't spinning at the rate we expected it, given the amount of matter we saw in the galaxy. It implied that the spin rate implied that there should be much more matter there than we're seeing. And so hence the missing mass problem. People like Zwicky and others, were very involved in trying to solve it. Well, we haven't solved it after all these years. And, it was some years ago that I was in grad school. So you would have thought that by now we would have solved it. We haven't. But it's now called now it's called dark matter.
Right.
Okay, so
I can't say either of those names are particularly
I know. Basically, they both express the kind of a shrug, from science saying, well, it appears as there's more matter out there than we're able to see with our telescopes and other observational techniques. But we don't know if that's the case or whether our equations are just wrong, and they're causing us to expect there to be more matter than there actually is. So we're in a bind either way, and it's exciting. It's an exciting problem. Hey, listen, in science, problems like that are job security. Okay, they shouldn't rattle us, and they shouldn't rattle other people. The universe is a very mysterious place. That's the bottom line. Then the other more recent innovation is this, or observation, is this dark energy.
Right.
I remember being at ABC News when I was a science correspondent there, as you know, for about 14 years. I did Good Morning America, Nightline, and all those shows. And I remember when that story broke about the accelerating universe, and I remember I think I was still teaching at Harvard, and so I interviewed Bob Kirshner, who was very involved in that there. He was an astronomer, and he was very excited. Oh my gosh, this is one of the greatest discoveries. The universe is actually accelerating. It's not just expanding, but it's accelerating as it's expanding, which is completely what we didn't expect, right? Because in the standard Big Bang theory, the universe expands, but it should be slowed down by the pull of gravity, or at least maybe just it keeps expanding forever because there's a perfect balance between the outward forces and the force of gravity. But the idea that the universe is actually accelerating, defying gravity, was something quite remarkable. So what did we do? Well, there has to be something there to accelerate it.
Right. Yeah.
Something is pushing the accelerator. What is it? Well, let's call it dark energy. There's something there that we don't see that's causing the acceleration. So that's where we're at right now. We have these profound problems of dark matter and dark energy. And to be honest, and you know, because you're a scientist as well, and an observationalist, I'm a theorist, you're an observationalist, so you of all people know this is a huge thing, because now the estimates are that 95% of the physical universe, universe, right? That's matter and energy. 95% of it is invisible to us, which means, let's follow what this means, which means that our entire discipline of astronomy, of physics, of everything we call science, the entire schmagegi is based on just observing 5% of the physical universe. Wow. I mean, can you imagine living long enough that if we do unveil that other 95%, how will that change our astronomy? How will that change our physics? It's pretty mind-boggling.
You know, it really is. And there's this sense that we kind of have everything sorted out. We've got all the problems figured out, if you will. But, I think your comment is intriguing there, that where we find these problems, that's what's actually fun and fascinating.
That's the fun.
But there's also we just see that the creation is much bigger and more bizarre and more creative than we ever would have thought.
Which is interesting, because that's what the Bible has said all along, right? The Bible has said all along that, there are principalities and there are forces at work beyond the visible universe. And so I find it rather intriguing that as science chugs along in its effort to understand the universe, it's actually coming into greater and greater conformity with this truism that is espoused by the Bible, not less so. That's a big deal.
Hello, Jeff Zwarenk here. Welcome to Science Faith Connection, the segment of our show where we look at important scientific discoveries and see how they point to the truth of Christianity. Today, I'm joined by my friend and a good colleague, Dr. Michael Strauss, and we're going to be talking about particle accelerator searches for dark matter. Mike, it's good to have you here today.
It's always a pleasure to be with you.
So this is a kind of a topic near and dear to my heart. I am involved in searches for dark matter, only we're building balloon experiments to put up on top of the atmosphere and looking for exotic particles. I know you do stuff that is related to dark matter as well, particularly your searches over at CERN. Why don't you give me just a couple of minutes, kind of describe the work you do, and then we'll get into the details of what your work says about whether dark matter exists.
Yeah, so I work at the CERN laboratory in Geneva, Switzerland, which is the world's largest particle accelerator. We smash protons together at the speed of light and 40 million times a second. And we build these huge detectors to see the debris from those collisions and understand the structure of the universe and mysteries like dark matter that we don't know anything about yet.
Well, very good. I have to say, anytime I think about what sort of detectors you guys have built, just the scale of them and the fact that you can do that level of detection at that time scale, it's really pretty phenomenal. So tell us a little bit, how do particle accelerators play into our search for dark matter? What are they trying to find?
Well, we know that dark matter interacts with regular matter by gravity. We see the effects of it in things like galactic rotation and gravitational lensing and things like that. But the idea is that maybe they also interact with regular matter in other ways. And so maybe we can create dark matter particles, for instance, by smashing protons together. Einstein's famous equation, E equals mc squared, means that mass is a form of energy. So when we smash particles together, we can use the energy of their collision to actually create mass. And one of the things is that we're hoping that maybe we'll actually be able to create these fundamental dark matter particles and then detect them in our big particle detectors.
So presumably in these big collisions, this isn't going to happen very often. Seems like you have to sort through a lot of data to find the ones you are. What are the signature, or what kind of signature do you look for that says, we found a dark matter particle?
Yeah, that's a great question. So you look for nothing, actually. And so what do I mean by that? Well, dark matter doesn't interact with regular matter very often. So when the particles collide, we know that, we have a whole bunch of protons going one way and a whole bunch of protons going another way, and they have equal and opposite momentum. So their initial momentum is zero. And since momentum is conserved, when they collide, the final momentum of everything we create should add up to zero. Technically, in the plane perpendicular to the collision, we call it transverse momentum. And if we add up all the momentum or all the energy in that plane and it doesn't add to zero, it means that there's something that escaped our detector undetected. And that one of the options of those things that might escape the detector undetected would be dark matter. So for instance, if we had a whole bunch of particles go this way and nothing go that way, we know that something must have recoiled the other direction. We call it missing transverse energy. And that tells us or infers that a particle goes there. Now, there are particles that we know about that actually go through the detector and create this missing transverse energy, particles called neutrinos, which are part of the Standard Model. And so what we would look for is an excess of these kinds of events. And there's actually multiple ways to look for dark matter in our detectors, but that missing transverse energy or lots more events than we expect with that would be one signature of possibly dark matter.
So in all of the particle accelerations, the collisions that have happened over at CERN and in your work, what have you found? Have you found any evidence for dark matter at this point?
Yeah, if we had, you would have heard about it, of course. No, so we've done searches, we've written papers on looking for it. And so far, everything that we have observed doesn't give any indication of particles outside those we already know about in the Standard Model particle physics. In other words, we haven't seen any indication of anything like dark matter beyond what we already know about.
So what are the implications for that? I mean, obviously, if we found the dark matter, that would just be really cool. I mean, Nobel Prizes awarded, lots of new experiments to try and figure out what's going on. What does the state of dark matter searches as far as particle accelerators go? How does that interact with the Christian faith at all?
That's a great question. That's not usually a question I think I ask myself as a scientist necessarily. For us as physicists looking for something new, it's very frustrating. We expected when we turned on the Large Hadron Collider in around 2008 or so that we would actually see many new things beyond the Standard Model of particle physics, and we haven't. And so we haven't seen dark matter. I think one thing it tells me is that nature is, much more complex and intricate than we hope it is. Whenever we have a simple model of nature, like the simplistic model of supersymmetry, which might actually be a dark matter candidate, we look for it and it's not there. And nature always surprises us. Some of the greatest discoveries were things that were not predicted by our model, but were unexpected. And so I constantly am amazed at the creativity of the designer behind it all, because much of what we find is not necessarily what we expect. And when we find dark matter and figure out exactly what particles it is, I'm convinced we will someday, it may not fall into any of our models. And that may tell us even again that whoever's behind it all is much more imaginative than we as humans are.
So you're using terms like creativity and surprising. I mean, those are the ideas of a mind behind, or, those words connote that. What brings you to conclude that there's a mind behind this, rather than, well, it's just something big we haven't solved, give us time, we're going to figure it out, and there's no real God behind it?
Well, I don't think those two are necessarily incompatible, in the sense that when we figure something out, it may be indicative of a creative mind behind it all, right? If I can figure out how a robot works, it doesn't mean that there's nothing behind it. In fact, when you look inside the details of a robot, you would go, wow, this looks like there is something more than just random chance behind it. And this is how I see much of what I do in my field of particle physics. The intricacy and the design, I mean, it's so well put together, and it's so much more imaginative than humans come up with. It seems to be like there's something behind it all. Does that guide my research? Well, in some sense, yes, because we expect things to be ordered, right? This is part of the scientific revolution in Western world, is that we expected that a God like the Christian God would create an ordered, reproducible world that we can study. And when we do, we find it remarkable. We're in awe of it.
Well, thanks. Little bit of an oddball question here. Is there one particular discovery that you've run across in your work that points to that design elegance that says, yeah, that really, I think that's powerful evidence of a creator?
The one I really like is the subject of what we call virtual particles. And in subatomic physics, particles pop into existence apparently from nowhere, from the space-time continuum, really, and then they go away. And inside every proton in your body, there are virtual particles popping into existence all the time and going away. And those virtual particles change the mass of the proton just slightly, in such a way that the mass of the proton is finely tuned, ultimately, to allow life to exist. So if you didn't have particles popping into existence from nowhere, there's a chain of events, which means we wouldn't have life. Who would ever think of something like that?
Well, that's a pretty ingenious design, if you ask me. Thanks, Mike. I appreciate your comments. When we do go look at creation, when we study using our particle accelerators, our telescopes, we find that there is this just fascinating world, very orderly, well put together. And the more we learn about this creation, the more it points to the ingenious mind behind it. If you found this topic interesting and would like to hear more, would encourage you to go look on YouTube for our podcast, Stars, Cells, and God. Mike and I discuss these sorts of ideas and the fine tuning and Higgs searches as well. Great topic to go look to equip you to be able to share the gospel with those around. Go look for Stars, Cells, and God, episode number 10.
We hope this technical episode of 2019 has helped equip you to share your faith with compassion and confidence.
I feel like this is one of those topics where it can be over a lot of people's heads, over my head too, but I really like how Hugh and Michael and Jeff and Mike, they were able to kind of explain dark matter in a way that shows really the intention behind the vastness of the cosmos.
Right,
yeah.
Right. And if they can explain it in a way that someone like me can understand, I'm sure people out there understood as well. So I thought it was a great episode.
It definitely was. And if you'd like to stay in touch with us, be sure to find us on Facebook, Twitter, and Instagram. We are at 2819 Show. We'd love to hear your thoughts. Maybe you have a topic idea that's something a little easier to digest.
And if you would like the audio version of the show, you can find us on most major podcast services. Just search Reasons to Believe Podcast.
See you next week.
See ya.